What makes decision making difficult and challenging? Uncertainty is probably the number one challenge. If we knew how much the demand will be for our product, we could do a much better job of planning and scheduling production. Or if we know exactly how long each step in a project will take to be completed, we could better predict the project's cost and completion date. Or if we know how stocks will perform, investing would be a lot easier. Another factor that makes decision making difficult is that we often face such an enormous number of alternatives and that we cannot evaluate them all. What is the best combination of stocks to help me meet my financial objectives? What is the best product line for a company that wants to maximize its market share? How should an airline price its tickets so as to maximize revenue? So we have the business analytics. So it is a scientific process of transforming data into insight for making better decisions. And it is used for data driven or fact based decision making, which is often seen as more objective than alternatives for decision making. As we shall see, the tools of business analytics, like this can aid decision making by like creating insights from data, by improving our ability to more accurately forecast by planning. So we can plan through the forecast, or by helping us quantify risk, or and also yielding better alternatives through analysis and optimization. A study based on a large sample of firms that was conducted by the researchers at MIT's um, Sloan School of Management and the University of Pennsylvania concluded that firms guided by data driven decision making have higher productivity and market value and thus increased output and profitability. So, business analytics can involve anything from simple reports to the most advanced optimization techniques. So, those methods for finding the best course of action. Analytics can or is generally thought to comprise the three broad categories of techniques: the descriptive, predictive, and the prescriptive analytics. Descriptive analytics encompasses the set of techniques that describes what has happened in the past, from the word descriptive. Examples are data queries, reports, descriptive statistics, data visualization, including data dashboards, some data mining techniques, and the basic what if spreadsheet models. A data query is a request for information with certain characteristics from a database. For example, a query to a manufacturing plant's database might be for all records of shipments to a particular distribution center during the month of March. Um, Also, this query provides descriptive information about these shipments, the number of shipments, how much was included in each shipment, the date each shipment was sent, and so on. A report summarizing relevant historical information for management might be conveyed by the use of descriptive statistics, like the means, measures of variation, and the data visualization tools like tables, charts, maps. So, simple descriptive statistics and data visualization techniques can be used to find patterns or relationships in a large database. So, data dashboards are collections of tables, charts, maps, and summary statistics that are updated as new data become available. Dashboards are used to help management monitor specific aspects of the company's performance related to their decision making responsibilities. For corporate level managers, daily data dashboards might summarize sales by region, current inventory levels, and other company wide metrics. Also, the frontline managers may be viewed may view dashboards that contain metrics related to staffing levels, local inventory levels, and short-term sales forecasts. Data mining is the use of analytical techniques for better understanding patterns and relationships that exist in large data sets. For example, by analyzing text on social network platforms like Twitter. So data mining techniques like um, including the cluster analysis and sentiment analysis are used by companies to better understand their customers. So by categorizing certain words or the positive or the negative and keeping track of how often those words appear in tweets, a company like Apple can better understand how its customers are feeling about a product like the Apple Watch. So, predictive analytics consists of techniques that use model constructed from the past data to predict the future or ascertain the impact of one variable to another. For example, past data on product sales may be used to construct a mathematical model to predict future sales. This mode can factor in the product's growth trajectory and seasonality based on past patterns. Like a packaged food manufacturer may use point of sale scanner um, to scan the data from retail outlets to help in estimating the lift in unit sales due to coupons or the sales events. Survey data and past purchase behavior may be used to help predict the market share of a new product. All of these are applications of predictive analytics. So, linear regression, time series analysis, some data mining techniques, and simulation are often referred to as a risk analysis or fall under the banner of predictive analytics. So, we will discuss all of these techniques in greater detail in this text. Data mining previously discussed as a descriptive analytics tools, okay, and also often used in predictive analytics. Okay, so these are the techniques used in predictive analytics: linear regression, time series analysis, data mining, and also simulation. For simulation, this involves the use of probability and statistics to construct a computer model to study the impact of uncertainty on a decision. For example, banks often use simulation to model investment of default risk in order to stress test financial models. Simulation is also often used in the pharmaceutical industry to assess the risk of introducing a new drug. Prescriptive analytics differs from descriptive and predictive analytics in that prescriptive analytics indicate a course of action to take, that is, the output of a prescriptive model is a decision. Predictive models provide a forecast or prediction, but do not provide a decision. However, a forecast or prediction, when combined with a rule, becomes a prescriptive model. For example, we may develop a model to predict the probability that a person will default on a loan. If we create a rule that says if the estimated probability of default is more than zero point 0.6, we should not award a loan. Now, the predictive model coupled with the rule is prescriptive analytics. And these types of prescriptive models that rely on a rule or set of rules are often referred to as the rule-based models. Other example of prescriptive analytics are portfolio model in finance, supply network design models in operations, and also the price markdown models in retailing. So these are other examples of prescriptive analytics. Portfolio models use historical investments return data to determine which mix of investments will yield the highest expected return while controlling or limiting exposure to risk. Supply network design models provide plant and distribution center locations that will minimize costs while still meeting customer service requirements. Given the historical data, retail price markdown models yield the revenue maximizing discount levels and the timing of a discount offers when goods have not sold as planned. So all of these models are known as optimization models. That is, models can give the best decision subject to the constraints of the situation. Another type of modeling in the prescriptive analytics category is simulation optimization. So this combines the use of probability and statistics to model uncertainty with optimization techniques to find good decisions in high complex and high uncertain settings. So the techniques of decision analysis can be used to develop an optimal strategy when a decision maker is faced with several decision alternatives and an uncertain set of future events. So decision analysis also employs the utility theory, which assigns values to outcomes based on the decision maker's attitude towards risk, loss, and other factors. So, in this text, we all cover the three areas of business analytics. We have descriptive, predictive, and prescriptive. Now, okay, we have the um, three categories of the business analytics that we have already covered. Descriptive, that is to describe the past data, to be used for forecasting and predicting, and the use of rules in decision making for the prescriptive.